This is University Beat. I'm Mark Schreiner.
And the reason why it's called back substitution is because we are going backwards.
Watching USF mechanical engineering professor Autar Kaw teach his computational methods class is like seeing a well-oiled machine at work. There's a lot of fast-paced activity, but it's all very precise and thought through. The slightly balding man moves quickly back and forth between the students and a quartet of large whiteboards, which he fills with a series of grids of numbers. But the way Kaw teaches these complex mathematical equations isn't limited to markers and whiteboards. He's also come up with a number of innovative ways to use social media and technology to teach these vital theories. As a result, two organizations, including the Carnegie Foundation, have named Kaw a 2012 U.S. Professor of the Year. I talked to him about what it was like to be one of only 4 professors honored.
It's exciting. It's a recognition of the work which I have done with my colleagues, of course, for the last 11 or 12 years. And it shows a recognition of also of the undergraduate education, which is, I think, the most important mission of any university, whether it's a research university or a teaching university.
What is it about your teaching style that you think maybe sets you apart and maybe even contributed to you winning this award?
I believe in direct instruction, which does not simply mean that I'm a sage on the stage and delivering a lecture, but what I believe is that starting with a sage on the stage style and then going to the guide on the side style, which implies that you first give the instruction to the student because he's a novice, he's not an expert. Then you take away some of the support structure which you are giving him or her and let them learn on their own. Now, you're known as the numerical methods guy. You have a holistic Numerical Methods Institute website and blog, both at mathforcollege.com. You also have a series of well-received YouTube lecture videos with titles like The Gauss-Seidel Method of Solving Simultaneous Equations. What are these methods? Why are they so important to undergraduate engineering students? Well, most of the engineering and science problems, although we may be led to believe that they have exact solutions, that's not the case for 99% of the problems. If you look at the example of building a space shuttle, you'll find out that many of the problems which had to be solved in order for the space shuttle to go up in space, they were solved numerically, which means that they were solved by approximate methods. And the reason why we need approximate method is because, one, many problems, when they are modeled as a mathematical model, they cannot be solved exactly, and there are other problems which can be solved exactly, but they will take a long time to do so.
After the computational methods class, I catch up with mechanical engineering junior Mateusz Malinowski. He praises Kaw for not just educating him, but making the information come to life.
What he does is he forces you to think about the way that the problem is approached in itself, not necessarily just what the solution is. And what that allows you to do is really connect all the dots through all the stages that you've gone through while you were studying, and kind of get the bigger picture of what this means that you're actually learning, not just how to get the right answer.
And that kind of approach also fits in with the surprisingly simple advice that Kaw has for other teachers.
One is that you got to have high expectations of your students, and the second one is to develop an emotional connection with your students. So if you're able to do those two things, no matter what mode or methodology you use, I think you'll become one of the best educators in the world.
If you want to check out Professor Kaw's numerical methods videos and hear what he thinks of the role technology will play in the classroom in the future, visit the University Beat link on our webpage, WUSF.org. For University Beat, I'm Mark Schreiner. The idea of the YouTube videos, the website, does that help you get your ideas out to more than just the students here on the USF campus?
I get emails every day from all over the world, either telling me that they like the videos which I have put up on YouTube, or they may simply be asking questions about some doubts they may have about some of the methods which have been described in the YouTube lectures. It's a course which almost half of the engineering students take all over the world. So it's a core course, so it's not like an elective course. So a lot of people have issues with understanding the subject matter. They may not understand it in the class itself because most of the classes are only 50-minute lectures. But if they want to review the material, it's a good way of understanding the material again. They can rewind me again and again till they understand the material. And also what I believe in is that by having the website and having the YouTube lectures and being able to communicate through Twitter, what we have tried to do is to get the resources in many different contexts So once you have, let's suppose if I have a YouTube lecture, I have a textbook chapter, I have multiple choice question exams, I have simulations, you have developed worksheets in different languages, and if the student is able to see the same topic in different context, it has been shown by evidence-based research that it stays in your long-term memory as opposed to your short-term memory. What that does is that when they go to another course where they need to use the course material, they're able to recall the information much faster than they would have otherwise.
Do you, as an educator, see this as maybe the direction that education is taking, where it is going to be, the computer-driven, where someone in, let's say, China can watch your lecture from here in Florida and pick up the material and just simply learn it that way, as opposed to having to go to a brick-and-mortar college?
I believe that the brick-and-mortar college is here to stay, especially the good schools. If you look at Ivy League schools, they are here to stay. No matter how much we think that the computer or videos are going to replace the instructor-student interaction is extremely important. Let's suppose somebody watches the video and he develops some conceptual knowledge of a subject matter. It may not be the right concepts which he is developing. Time and again, I use clicker quizzes in my class, and I have assigned people to watch videos. And when I give the clicker quizzes in the class itself, I find that 50% of people are choosing A and 50% are choosing B. So I think that the mode of this instructor-student interaction may change, but I don't think it's going to be a replacement.
Now, there are professors like you, and there are Fulbright scholars around the university. What does it say for USF to have professors like yourself? What does it also mean to the students here?
Well, to the university means that we are putting emphasis on the Trinity, which I call as research, teaching, and service. That we are putting emphasis on all three, and we consider all three to be important. For the students, it means that they are getting individual opportunities. As you already mentioned, that videos are available for courses, so people might simply think, hey, I can take my 40 courses on the video and finish my degree. But the individual opportunities which are now arising, whether it is doing research with the professor as an undergraduate, whether it's to go to study abroad, whether it's to go for an internship, whether it's to go for a co-op training, all these opportunities which are now available to the student, they can be only available in a brick-and-mortar place. And I think with all these awards being given to our educators here at USF, it shows that they are doing the right things to take us into that direction.
It's also my understanding that one of your other pet projects is making sure that low-income students have access to higher education. Why don't you tell me a little bit more about that, please?
Education should be available to low-income students as well. Time and again, we see that many of the opportunities do not go there, whether it is to be able to support them through grants such as Pell Grants, or whether it's to develop loan programs for them so that they can return them in a reasonable amount of time. About 34% of the brightest students do come from the top quartile. We still have 17% of the brightest students coming from the lowest income quartile. And to give them the opportunities to be able to get a decent undergraduate education, I think that's an obligation of society.